So we are going to do a couple of concepts revolving around acid-base chemistry. A couple of things we're going to study in this demonstration is conductivity of solutions, acid-base chemistry, titration, endpoint determination. We're also going to look at the dissociation of ionic compounds and ionization of energy and precipitation reactions. So what I have right now sitting in the beaker is I have distilled water in a beaker, and I have a conductivity tester in the distilled water. The conductivity tester is just a fancy name. Will it light the light bulb? Notice that the distilled water will not light the light bulb because distilled water, or water in general, will not dissociate 100%. It's very reactant favored, H2O, lots of it. So notice it's not on, so there are no ions in there. So what I'm going to do first is I'm going to throw in some solid barium hydroxide. Barium hydroxide is a base. It dissociates 100%. I'm going to put a little in. Notice a couple of things occur. Notice that my distilled water is very cloudy looking. Barium hydroxide does not dissolve thoroughly. There's still some chunks at the bottom if you notice. I'm going to turn this up. Also notice that my light bulb came on. And my light bulb came on because barium hydroxide will dissociate into barium ions and hydroxide ions. I'm going to let that spin for a little while. See if we can dissolve some more, because of course increased agitation will make the dissolution process a little better. The light's really bright. Okay, now what I'm going to do is I'm going to put in a couple of drops of phenolphthalein. Phenolphthalein is an acid-base indicator. Phenolphthalein will be clear, colorless in an acid, pink in a base. And because barium hydroxide consists of hydroxide ions, which are bases, it goes very pink. The light's still on because nothing's been removed, no ions have been removed. So all I did was just the indicator turned pink because of the hydroxides. Alright, now so the very first one is the solution. I put barium hydroxide in water, and it dissociates into the barium ions and the hydroxide ions. Now, in my burette here, I have sulfuric acid. Sulfuric acid is a strong acid and will dissociate into the sulfate ions and the water, hydrogen ions, beg your pardon, hydrogen ions. The hydrogen ions and the hydroxides will form water. So what happens is those ions get removed from the solution. Slowly, because I'm only going to put in a few hydrogen ions at a time, but eventually I will remove all the hydroxides and the hydrogens from solution. The other thing that's going to happen is the sulfate ion is going to bond with the barium ion and form a precipitate. So I'll be removing them from solution also and forming a precipitate. Alright, so my sulfuric acid is right here, and I'm going to pour some in. Now, what I'd like you to really notice is the fact that the solution is getting creamier looking. For lack of a better term, it looks more creamy. That's because the barium sulfate precipitate is white and it is forming in the solution. The light's still on, so I still have lots of ions in there. Put some more acid in. Alright, I'm going to turn that off, let that sit for a little while. Again, notice how creamy, milky, creamy, if you will, the solution is getting. Now, alright, so I'm going to give you kind of a close-up view. If I can do this right, I will get the light and the solution in view here. Kind of a downward angle, if you don't mind. Okay, so now, see how creamy white it looks? Milky. What I'm going to do is I'm going to put more acid in it. Now the reason I turn it off every once in a while is because it has to reestablish equilibrium. Equilibrium just doesn't occur. So, creamy white. Oh, well, not white, I shouldn't say white. Creamy pink. Lots of barium sulfate. I'm going to start. Notice that the light bulb is starting to get dimmer. Alright, so our light bulb has gone out. So I'm going to put a little more acid in because just a touch. Okay, now notice light bulb out means no more ions in the solution. The hydrogen ions have all formed water with hydroxides on a 1-to-1 basis. And the barium ions have formed barium sulfate. That's what the precipitate is there. Now what we're going to do is we're going to add excess sulfuric acid. Bam! Look at that. Pure white. We are totally at the end point now. No ions in solution, so the little pink was a little before it. This is pure barium sulfate in water. And if I filtered it, I would be able to dry it and have barium sulfate crystals and nothing but liquid water. And now I'm going to go over a little bit. I'm going to go excess now. Put in some excess acid. And I'm going to make the light come back on. There it is. Light's coming back on because sulfuric acid forms ions. Now I can't. And I've got ions again in the solution.